Before we go to the next two sums, the 8th and the 9th one, we need to learn how to calculate volume of water in a running river or volume of water coming out from a tap. In all the earlier sums, the volume when we calculated it was of a stationary object. Here we are going to learn volume of flowing water, how to calculate volume of flowing water. Now before we go into this explanation of this, you'll definitely agree that if water in a tap flows at a high speed, the amount of water flowing out will be much larger. If the water in a river is flowing with a very slowly, then the amount of water flowing, the volume of water in that river will be less because the water is flowing at a slow speed. So faster the water comes out from a canal or flows out from a tap, faster is the speed, more is the volume. Less is the speed, less is the volume. So the volume of water in all these cases will depend on the speed of the water. In the first case, I have a canal which is like a rectangle, and from there is this water that is flowing out. And you'll definitely agree, if I have a rectangle like a cuboid, the water flowing out from a canal like this, a cuboid, and here is the water flowing out from it. The water flowing out from this will also be the same shape of that of a cuboid. So when I'm finding this volume here, this will be like a cuboid. I will use the formula of cuboid where I'll say volume or water is length into breadth into height. Let us say that the breadth of this cuboid is 5 meters and the depth of this cuboid canal is 2 meters. And the speed with which the water is flowing is 3 meters per second. So in 1 second, let's find out how much of water is flowing out of this cuboid. So here we have the canal. We write the dimensions again of the canal. That is 2 meters in height, 5 meters in breadth. Now I want to know the amount of water flowing in 1 second. So now there is water flowing here in 1. Now in 1 second, the water keeps flowing for 1 second. We know the speed for 1 second is 3 meters. So in 1 second, the length of this cuboid will be 3 meters. So this whole cuboid, this entire cuboid will give me the volume of the water, and the volume of the water, like I said earlier, will be length into breadth into height. Now we know the length is 3 because we are calculating for 1 second, and for 1 second it covers a distance of 3 meters, and the breadth, as we said, was 5 and the height is 2. So it will be 30 meter cube is the amount of water that is going to flow out of this cuboid of this canal in 1 second. Now to make things a little more clear, let us see now what would happen in 5 seconds. How much of water will flow out in 5 seconds? Here again I have the same cuboid whose height is 2 meters and the breadth is 3 meters, and again the water is now flowing out, but now the water is going to flow for 5 seconds, which means it's going to flow a little longer. For 5 seconds, the time is 5 seconds. So this again will be a cuboid. This is the distance it covers in 5 seconds. So this here, this volume of water I need to calculate. Again, this volume of water, since it's a rectangle cuboid, length into breadth into height. Now the breadth and the height we know. This is the 5 and 2. What about the length? The length will be, definitely you'll agree, is the distance covered by water in this 5 seconds. So length will be equal to distance covered in 5 seconds. And what is distance? Distance is speed into time. What is the speed of this? We know the speed was 3 meters per second and the time here is 5. So the distance is 15 meters. So this distance here, this distance here which is the length of this cuboid, is now 15 meters. So I will put now 15 meters. So the length is always given by the distance covered by the water in that time, which is now 150 meter cube. This is the amount of water that will flow in 5 seconds. Let's get up for another one. Let's find the water flowing in now 20 seconds. Same cuboid, the same canal. So I'm drawing my canal again, and the same dimensions of my canal, which is 5 meter here and 2 meter here. Now the water, I want to know the water flowing in 20 seconds. So 20 seconds means it's going to go way quite longer than the earlier one. So this is the water flowing. It will travel a longer distance. So this is the water in 20 seconds. You agree again that it is a cuboid, and hence the volume of this water will be length into breadth into height. Now the breadth and the height we know is 5 and 2. What about the length? The length is this of the cuboid. This is the length of the cuboid, and it is a distance traveled by the water. It is a distance traveled by the water in distance in 20 seconds, which is speed into time. The speed we know of this water we have taken is 3, the time is 20, so it is 60 meters. It travels a distance of 60 meters. So this is 60 meters. So I put 60 here. So it will be now 600 meter cube is the volume of water flowing in 20 seconds. Now let's get on to if the water is coming out from a cylinder like this, a cylindrical shape like this, or from a tap. Have you seen from a tap? It comes from a circular portion. You'll agree the water that is flowing out now will not be a cuboid, but it will be a cylinder, the shape of a cylinder. This water that is coming out, of course it spreads out here, but if the water were not to spread out, it would be a shape of a cylinder. So here I have like a cylindrical canal, and I will say the radius of this cylindrical canal is say 2 meters, and the water is now flowing out of it at a speed of, let's say the speed of this water is 5 meter per second. Now I want to know how much of water is going to flow in say 2 seconds. My sum is to find the amount of water flowing in 2 seconds. So here now the water is going to flow out for 2 seconds. It's flowing out. This is the amount it travels for 2 seconds, and you definitely agree the water now is going to be in a shape of a cylinder. It's going to be the water coming out will be in the shape of this cylinder. So when I'm calculating now the volume of water, it's going to be pi r square h. Now the pi is 22 by 7. The r is given to me as 2 meters. I've taken it here, 2 square. Now what will be the h of the cylinder? This is the h of the cylinder here. What I've marked here is the height of this cylinder. And you'll definitely agree the height of the cylinder will be the distance traveled by the water. Traveled by water in that stipulated time in 2 seconds. So the distance is speed into time, and in this case my speed is 5 and my time is 2. So it is 10 meters. So this height is 10 meters. The height of the cylinder is 10 meters. So this will be 10 meters. So the volume of water will be 2207 into 4 into 10 meter cube. Now we'll see volume of water flowing out in say 7 seconds. So I have the same cylindrical canal from where the water is coming out, and the radius of this canal we said was 2 meters, and now the water is flowing for a little longer time, and that is 7 minutes. So it'll travel a little longer distance like this. In 7 seconds it travels till here. So I get here this shape of mine is that of a cylinder, the water in 2 seconds. So I will make volume is pi r square h. So that is 22 by 7. My r is that of the, this is the r which is 2, which is given here. So I will write here 2 square. And now the h of this cylinder will be this distance. Distance for water traveled in how much time? In 7 seconds. So the height will be distance in 7 seconds. And you know how we calculate distance? Speed into time. So the distance is speed, which I know in this case is speed is 5, time is 7 seconds, so the distance is 35 meters. So this distance is h is 35 meters. So I will put 35. This will give me the volume of the water in 7 seconds. To summarize it, if your water is coming out from a cuboid, you will write volume is length into breadth into height. The breadth and height will be given to you. However, the length will always be speed into time because it is the distance traveled by the water. So it will be breadth and height. But however, if your water is coming out from a cylinder, like from a tap or any cylinder, cylindrical shape, then the volume of water in this case will be pi r square h. And here pi, the r will be given to you. However, the h will be now your speed into time. So these two formulas you need to remember.